Hello, sixth grade. So today we're going to be working to start preparing for our benchmark next week, at the beginning of next week. And so we're going to go over some review topics that we haven't done since earlier in the year, but that will be really important to know for our benchmark. All right, so the first side of the page is going to be combining like terms, which all of you used to be very, very good at. So we have 10x minus 7, 10x minus 7x plus 3 plus 4. All right, so first thing I'm going to do is I'm going to look through this problem and look for the terms that are like terms. So first, I know that if they have the same variable without a power, so if it was x squared, it wouldn't be a like term, but if they have the same variable, then they are like terms. But I also know that the sign in front of the term is very important as well. So I'm going to underline, or for the x's, I'm going to put a circle around all the terms that have an x. So I have two terms with an x, and I'm going to make sure to include that sign at the beginning because that's going to be important. That tells me whether I'm adding more x's or taking away the x's. And then I'm going to underline all my constants. Constants are the terms without a variable. So I have plus 3 and plus 4. And then usually I would rewrite it, putting all the like terms together. For this one, they're already together, so I'm just going to rewrite it below. 10x minus 7x plus 3 plus 4. And then I'm going to combine my like terms. So I'm going to combine my x's. So I have 10x minus, or take away 7x's. So that's going to be 10 minus 7, 3x. Because if I have 10 x's and I take away 7 of those x's, I'm left with 3. And then I have plus 3 plus 4. So that's just plus 7. So my final answer is going to be 3x plus 7. All right, let's look at one more problem. So in the next problem, I have 4x plus 2y, 4x plus 2y plus 5 minus 2x plus 3y. So the first thing I'm going to do again is circle my like terms. So here I have an x, and so I'm going to look for terms that also have an x by it. And then here I have minus 2x. Remember that sign in the front. Oops, you can see all of it. The sign in the front is really important. Okay, so those are all of my terms that have x in it. Now I'm going to look. I also have two terms with y in it, so I have another variable. So I'm going to underline all the terms that I have with y. I have plus 2y and plus 3y. And lastly, I have my one constant plus 5. So I'm going to rewrite this all, putting my like terms together, starting with my x's because that's my first term. So I have 4x, I see over here, minus 2x plus 2y plus 3y plus 5. And then again, I'm going to combine my like terms, or the terms that have the same variable or don't have a variable at all. So I have 4x minus 2x. So I have 4x, and then I'm taking away 2x's. So it's going to leave me with 2x. And I keep my sign here, plus. Then I have 2y, and I'm adding another 3y. So I'm going to have 5y plus my constant, which is 5. So I have 2x plus 5y plus 5. That's my final answer. All right, so that's the front of the worksheet. Then if you flip the worksheet over, on the back, we're working on reflections. And I already put the 3 things that you're going to have to know to be able to complete all of these problems. The first is that if you reflect over the x-axis, the x-coordinate stays the same, and then the y-coordinate becomes opposite. If you reflect over the y-axis, the y-coordinate stays the same, then the x-coordinate becomes opposite. Then if you reflect over both axes, then you have to change both coordinates to their opposite. So let's look at this for 2 problems. So if negative 5, 4 is our first point. And the problem says if negative 5, 4 was reflected across the x-axis, what would the new point be? So This is our x coordinate. This is our y coordinate. Oops. And it's being reflected over the x-axis. So that means if I look at my rules, that's rule number 1. To reflect across the x-axis, you keep the x-coordinate, and then you make the y-coordinate its opposite. So if you reflect -5, if you reflect -5, 4 over the x-axis, the x-coordinate stays -5, and the y-coordinate becomes the opposite of 4, which is -4. Let's try one more. All right. So the next one says if 3, 4 was reflected across the y-axis, what would the new point be? So if you reflect it across the y-axis, we have our x-coordinate here and our y-coordinate here. And when you reflect over the y-axis, the y-coordinate stays the same, and the x-coordinate becomes opposite. So we'd have -3, 4. Okay, go on and try the rest of the problems on your own on both the front and the back. Good luck, and let me know if you have any questions.